Hey students, my name is Mr. Acosta, and today we're going to be going over linear and nonlinear functions. And specifically, we're going to be going over what makes them different and how we're able to differentiate them. But before we delve into this, the learning objective for today's lesson is that by the end of this lesson, you'll be able to interpret the equation y equals mx plus b as a linear function, which is a graph with a straight line. And you'll also be able to give examples of nonlinear functions. And you'll demonstrate these skills through the completion of this lecture video and your participation in a Kahoot quiz at the end of this lesson. Awesome. So, before we start, have any of you heard of a linear function or of a nonlinear function? Does anyone have an idea of what they are? You can go ahead and think about that while I get ready. So linear functions. Let's start with that. What is a linear function? What is a linear function and how do I identify one? So here we have the function y equals x, which is our basic line. And linear functions, hence the name, linear comes from line. They're always a straight line. Graphically speaking, they're always a straight line. And they are usually in the form of y equals mx plus b. Learn this formula. This formula you'll use up until calculus and beyond. This is key. M being the slope and b being the y-intercept. Make sure you know this formula. When you see this formula, think of line. And the degree of a linear function must be 1. They are always of degree 1. So, just to recap this section, what elements does a linear function have? Make sure to study those and have them ready. Let's move on to the degree of a function. Have any of you heard of the term degree? It's not the degree that you earn in school if you go to university. It's a different type of degree. So the degree of a function refers to the greatest exponent value on said function's x variable. It might seem a little confusing, but don't worry. Once I show you some examples, it's very clear. The degree of a function is what tells us if a function is linear or not. So for example, here we have the function y equals x squared. Notice that the biggest exponent on the x variable is 2. So this function, the x squared function, is of degree 2. Similarly, this logic applies to other functions, even with multiple terms. We have x to the 4th power plus 2x squared. So we look at the exponents on the x variables. We see that 4 is the largest, right? So then that means that this function is of degree 4. So given that information, I want to ask you guys, what degree is this function? I'm going to give you guys some time to think about it. Okay, so you guys noticed that there's 3 x terms, and one term is squared, one term is it has a 4th power, and one term has the 9th power. What term is the largest? Obviously the 9th. So this function is of degree 9. Awesome. So let's move on to our last segment, which is nonlinear functions. What is a nonlinear function? So as the name entails, quite explicitly, it's a function that is not linear. So if a linear function is a line, then a nonlinear function is not a straight line. So as an example, I use the x cubed function here. As you can see, it's like curvy, and there's there's curves and like waves to it, it's not a straight line. And nonlinear functions have many algebraic forms. They can look something like this and have multiple x terms with different exponents. But the key of identifying a nonlinear function is this, is its degree. And mainly that its degree is not equal to 1. It could be less than 1, it could be greater than 1, but it will never be equal to 1. So an example of nonlinear equations could be the cubic equation, how I wrote up here, y equals x cubed, or the radical equation, radical function, which is y equals square root of x, which is algebraically the same as x to the 1/2 power. Notice that 1/2 is less than 1, but it's still not 1. A nonlinear function cannot have the degree equal to 1. Because if it does, then it would be linear. So, yeah, the key here, graphically, there's graphical differences between linear and nonlinear functions, and algebraic differences between linear and nonlinear functions. So, for nonlinear functions, if I asked you students to give me some examples of some nonlinear functions, what would you give me? Think about that for a second. Thank you for your time. And now that you're equipped to complete today's Kahoot quiz, you'll be able to differentiate linear from nonlinear equations. Have a good day.